Yesterday I did my first model using Amazon machine learning, and we got a F1 score of 0.608. Now, I was a bit confused. It was predicting home wins with an accuracy of 90%. So we just looked at how there seemed to be an upper limit of 70%. There was randomness. The example of the coin toss, that with coin tossing, it's going to be heads or tails 50-50. So the best accuracy that a model can get would be 50%. So how can it do so well? So then I messed around on R, using the same data file to kind of go, what do you find? And then I kind of thought, I have to be a bit careful. In the actual data file, which I've put up on Amazon, there are many, many columns of data. In R, I was kind of careful to make sure that, okay, I am now trying to predict the full-time result based on these 4, 5, 6 columns of data. So what the away win rate is, what the away loss, the home win, that kind of thing. But when I loaded up the data onto Amazon, I just loaded up the entire file. I never told it that, okay, look, you're allowed to use this, you're not allowed to use that. In particular, the file said how many goals the home team scored in one of the columns and how many goals the away team scored. Now, if you were allowed to use that data, of course you're going to do very well. If I tell you that the home team scored 3 goals and the away team scored none, can you predict what the full-time result is going to be? Not only do I expect you to be able to predict what the result's going to be, that it's going to be a home win, I expect you to be able to even predict the score, because I've told you how many goals the two teams have scored. So what did this model use? That I hadn't. Again, this was my first go, so I just loaded up the entire data file with all the data up onto Amazon and told it to try and predict the full-time result. So who knows what it did? So I created a new file just for this Amazon model where I removed how many goals the home team and the away team had scored. So, there's no way that it can cheat. It didn't cheat because it didn't know that it wasn't supposed to use how many goals the teams had scored. But of course you can do better if you have that information. In fact, I would expect it to do far better. So there's something strange going on there. Also, although I did another evaluation of the model, and got everything 100% right. So there it had obviously realized that, I actually have the scores. So this is the evaluation that I had yesterday with with the actual scores within the data. Now, of course, it doesn't know that number is a score. The machine just looks at this data. So the fact that it has 2 and the home goals column has a 1, that's just a number. And it has many numbers. So it wouldn't know that the key result is comparing the full-time result, the goals scored by the home and the away team. So here's the new data where, as I said, I've removed the goals scored by the home and away team. So I'd expect there to be a change in the performance. So F1 was 0.61, the total. Okay. And for the new one, sorry, I'm just going to go back. Okay. So that I can compare. So here's what we had yesterday. An average F1 of 0.6, baseline F1 of 0.22. Again, I'll have to look up what this F1 business is. I'm more used to R, where I'd be using kappa. And here's the new one where it doesn't have the scores. And F1 has dropped to 0.542. Okay. And then I can explore the model. And I'll explore the model here as well so that I can jump between the two. Okay. So in yesterday's model, when it was a home result, it called a home result 90% of the time. Okay, so the top part is the predicted, and this is what the actual result was. So when it predicted it was a home result, 90% of the time it was. So 27 times out of, what's the total? Oh, yeah, total is 35. So 27 out of 35. When it's predicted it was going to be a home result win, it was a home win. 10% of the time it predicted, 10% of the time that it predicted it was going to be a home win, it was actually an away win. And 54% of the time that it predicted it was going to be a home win, it was actually a draw. Okay. I've said that wrong. So this is the true value. So 54% of the time that the match was a draw, because these add up to 100. So 54% of the time that the match was a draw, the model had predicted that it was going to be a home win. So that's the way. Okay. So now look at the new model where it doesn't have the score data. Okay. So again, 54% of the time. So this seems to be very similar. 80% of the time that it was a home win, it had predicted it was going to be a home win. So that's down from 90. And 31% of the time that it was an away win, it had predicted it was a home win. Okay. So basically the numbers have come down a bit. Let's try and keep an eye at what's going on here. So there are 60 games in total. It predicted correctly that it was going to be a home win 24 times out of 60. So it's right less than half the time. And that's for a home win, which is the best. 10 times it got so there's 37 times it got it right. 24 plus 10, 34, 35, 36, 37 times it got it right. And 1, 6, 7, 8, 9, 10, 11, 17, 23. So 23 times it got it wrong. I'll put that down. Sorry. Yeah. Wrong 23. Right 10, 34, 35, 36, 37. So it's right more than half the time. And what's 37 over 60? Okay, so 61% of the time it got it right, which is very good, right? Because the upper limit is supposed to be 70%. And it's annoying. This is the wrong one, sorry. This is the model where it doesn't know what the scores are. So I just count that again. So 24, 34, 35, 36, 37. Yeah. So we got it right 61% of the time. So well done, Amazon. I mean, if it's getting the result right 61% of the time in matches that it has never seen before. So that's something I don't have any problem with. You know, as far as I know, it does not use any data like when I tell you the score, you know. And it's looking at data, looking at games which it has never seen before. So it is having to predict. So then the next step is to then use the real-time predictions. Okay. So what I do is, before a game is about to begin, like, so say I have Chelsea are going to play Arsenal. All I have to do is enter in all these numbers. So the 23 numbers. Like the first number isn't relevant. So it is ignored in the model. It knows that it's not a. So all I have to do is enter in those 23 numbers, and then it will apply the model and predict what it expects to do. And as we saw, this model got it right 61% of the time, which I would be very happy with. Before I kind of go, oh, that's fantastic, you've got to remember also that this model does use data about what the result is at halftime. And that allows you to, do better. Because obviously, if one team is, if you're losing at halftime, you're less likely to win. I just want to do one more thing. So how well did the flawed model, where hidden within the data, the score, like I'd given it the score. Well, there, 27, 37, 41, 42, 43, 44. So it was 44 out of 60. So 73%. Now, that did send alarm bells ringing, because, as I said, we just did in the video a couple of videos ago, talking about how the upper limit seems to be about 70%. So if I come up with a model that is saying, oh, look, I can get it right 73% of the time, that's like somebody saying, I can predict what the coin toss is going to be with an accuracy of 60% or 70%. You can't do that. So that's just an update on the Amazon machine learning situation. That is good. I'm impressed by that. I mean, a 61% success rate is, I would have taken that happily. So now I'm going to have to go back to R to see what did it come up with. I mean, basically, is the Amazon model outperforming my model on R?